So we're going to go through this example here, and by going through it, we're going to get a better understanding of what the inverse function is. Okay, so the set of ordered pairs here is a function f. First, we are going to describe the inverse function of this function as a set of ordered pairs, and then we're going to give the domain and range of both f and its inverse. Okay, so let's begin by finding the inverse function. So to find the inverse function, what you do is you swap the position of the x and y. So instead of writing 0, 3, we're going to write 3, 0. So again, to find the inverse function, you simply swap the order of your x and y. So instead of 1, 2, you're going to get 2, 1. Instead of 2, 4, you're going to get 4, 2. And instead of 4, 5, you're going to get 5, 4. Just like that. So we have now found the inverse function. We simply swapped our x's and y's. The next thing that this question wants us to do is find the domain and range of both f and the inverse of f. So let's begin by finding the domain of f. The domain of f is simply all the x values of f. So 0, 1, 2, and 4. So I'm going to come over here and I'm going to list them out. 0, 1, 2, and 4. The range of f is simply going to be all the y values of the function. So it's going to be 3, 2, 4, and 5. 3, 2, 4, and 5. Perfect. Now what we're going to do is we're going to find the domain of the inverse function, which is simply going to be all the x values of the inverse. So it's going to be 3, 2, 4, and 5. 3, 2, 4, and 5. Then we're going to find the range of the inverse function, which is simply going to be all the y values of the inverse. So 0, 1, 2, and 4. 0, 1, 2, and 4. So 0, 1, 2, and 4. Okay, we're going to pause here for a second. I want you to see if you can notice anything interesting that has just happened. So have a look. Anything interesting? Hopefully you've all identified something. Pause the video if you haven't yet. But hopefully you can see that the domain of f has become the range of the inverse. And also, hopefully you've seen that the range of f has become the domain of the inverse. So as you can see here, 0, 1, 2, 4, 0, 1, 2, 4. 3, 2, 4, 5, 3, 2, 4, 5. We've simply swapped them around. And that's exactly what our definition told us above. So remember, if we come up here, the domain of f is the range of the inverse, and the range of f is the domain of the inverse. Okay, so there is a really important piece of knowledge right there. The next thing I want to show you is how we can visualize the inverse, and we're going to do that by looking over here. So what I've plotted over here is just the function. So 0, 3, 1, 2, 2, 4, 4, 5. If I now plot the inverse function, so all these points right here, so I'm going to put on 3, 0. So that would be down here. Then I would put 2, 1. 2, 1 would be 2, 1 would be here. Then I have 4, 2. 4, 2 would be here. And then I have 5, 4. 5, 4 would be there. So I've got 5, 4. I've got 4, 2. I've got 2, 1, and I've got 3, 0. And I might even put this down the bottom. Okay, now I again want you to look at this and see if you can identify anything interesting that has happened. Hopefully you can see something very interesting, and that is all my inverse functions have simply been reflected across the line y is equal to x. So this dotted line here is y is equal to x. And do you see how these inverse function points have simply just been reflected across? So look here. There, I've just reflected it across. And over here, I've just reflected it across. Over here, I've simply reflected it across. They're all just the mirror image over this line. So that again is going to be a really important thing that we have to observe. So we've seen a lot here, and hopefully you're getting a bit of an understanding of what the inverse function is here. All right, perfect. Hopefully this has made sense.